Okay, we're continuing with lesson 6.3, and we are on example 4. Okay, so this is very similar to the ones we were doing before where we were evaluating the expression, only this time we're solving. Woo, pen is way too fat again. So this time we're solving. So we're looking for x equals something. So it's the same idea where you're using your arrows, and we're starting with a log here. We're going to convert it to an exponential function so that we can solve. Okay, so 8 to the 4/3 equals n. So 8 to the 4/3 equals n. And then we just have to simplify this left side to find out what n equals. So first I want to write this as 8 to the 3rd root. Remember, the bottom is the root. And all of that to the 4th power equal to n. The 3rd root of 8 is 2. So then I'm left with 2 to the 4th power equals n. Or n equals 16. That's it. That is all there is to it. Let's look at another. Okay. Very, very similar. We're going to begin by converting it to an exponential using our arrows. So let's do blue this time. 27 to the 2/3 equals n. 27 to the 2/3 equals n. So now I just need to evaluate the left side here. So remember, this becomes my root. So I have 27 to the 3rd root, and all of that to the 2nd power will equal n. Well, 27 to the 3rd is 3. So I'm left with 3 to the 2nd power equals n. 3 to the 2nd power is 9. So n equals 9. So don't be alarmed. We got two things happening on both sides. We got logs on both sides, but I'm going to show you a really awesome trick. If you notice, I have a log 4 over here, and I have a log 4 over here, and I have an equal sign in the middle. Now let me show you over to the side here a property. It says if you have two logs with the same base like we have, and this is how the property is written, so log base b of something, in this case x, equals log base b of y, then that means x equals y. And similar to if we have b to the x equals b to the y, so we have the same bases here, then x equals y. So these two properties over back in our problem allow us to say, since we have log base 4 of x squared equals log base 4 of 4x minus 3, then we can go right ahead and say x squared equals 4x minus 3. And then I just have to solve this quadratic, right? That's a quadratic. So I need to set it equal to 0, so I'd have x squared minus 4x plus 3 equals 0. That's factorable. I have 3 and negative 4. So a times b, yep, 3 and negative 4. So that factors into 1 and negative 3, nope, negative 3 and negative 1. So I have x minus 1 and x minus 3 equals 0. So x equals 1 and x equals 3. And if I check both of these, which I can substitute them in here to check them, or I can substitute them in my original equation. I would find that both of those are solutions. Example 4, we've got that same thing. Log 5 of something equals log 5 of something. So I can say my two somethings that I have circled in blue there are equal to each other because they're both log base 5. So this is a lot the same as the other one. I want to write it in standard form for a quadratic. And then this quadratic is factorable, so I don't have to use quadratic formula. It factors into this. If you need to do Xbox, go ahead and do that and check me. But you'll find x equals -2 and x equals 3. So that is my solution. Okay, last part of this lesson is graphing. And these examples, you'll see, I'm just going to scooch this a little, give you all the steps here. So step 1 says convert the log to exponential form. Now this is written backwards from how we're used to looking at it. So I'm going to write it like that so we can do our arrows more easily. So in exponential form, this would be 2 to the x equals y. So that's step 1. And now step 2 says complete a table of values for the function in exponential form. So here's my x, and over here my y is going to equal 2 to the x. So when x is -2, I'd have 2 to the -2, and that would equal 1/4. When x is -1, I'd have 2 to the -1, which would equal 1/2. When x is 0, I'd have 2 to the 0, that equals 1. When x is 1, I would just have 2. When x is 2, I would have 4. And when x was 3, I would have 8. Okay, so I did that. Now it says step 3, find the inverse of the coordinates. So remember that means switch your x and y. So over here, I'm going to take my y, or my first y, and I'm going to write it as an x. So I'm going to switch all my columns here. Oops, that didn't work out very good. That was supposed to be -1. So all I'm doing here is switching the x and y. So this becomes 2, 1, 4, 2, and 8, 3. And then this is what I'm going to graph. Because remember in the very first video I said exponentials and logs are inverses of each other. So if I graph the inverse of the exponential, that's the same as graphing my log. It might be tricky for me to graph here on this small grid, but I'm going to start with this point right here. So, wait a minute, I think I have a mistake here. This should be +1. Okay, now let me go back here. Okay, so I want to go over 1 up 0, so I'm going to have a point right there at 0, 1. Over 2 up 1, hard to make these points. Over 4 up 2, and then over 1/4 down -2. So this is the shape I'm taking on. Okay, and what is the x-intercept? 1. And you will find the x-intercept is always going to be 1. The other thing I want to point out here is if you look at domain and range of this, the domain, the x values are always positive. So I only have x values on the right side of the coordinate grid. So it's different than when we did the exponential functions. Are these? So I want to, step 1, write it in exponential form. So in exponential form, this would be y equals 0.5 to the x. Now step 2 says complete a table of values for the exponential form. So that would be 0.5 to the x, and I'd have -2, -1, 0, 1, 2, and I guess 3. And you can do 0.5 to the negative 2. You could turn that into 1 over 0.25, which equals 4. And remember, you could do all that in your calculator. If you do negative 1, you're going to get 2, 1, 0.5, 0.25, and 0.125. So they're getting really small as I move this way. They're getting big as I move the other way. Now over here I want to switch my x's and my y's. So my negative 2, 4 becomes 4, negative 2. 2, negative 1. 1, 0, 0.5, 1, 0.25, 2, 0.125, 3. And need to slide over here a little. This is going to look like, I like to start by graphing my my x-intercept there, over 1 up 0. And then as I go this way, I'm getting closer and closer to x equals 0. And as I go this way, 2, negative 1, and 4, 1, 2, 3, 4, negative 2. So this one takes this shape. Once again, only positive values of x. So for a log function, the domain x must be positive or greater than 0. And the x-intercept is 1. Or here. This is a you try. So pause the video, try this, come back and look at the answers. Okay, here is your solution. You'll notice I didn't fill out this table. I just went ahead and gave you the inverse, and I gave you a very rough graph. Okay, section 6.3, we learned how to convert from exponential functions and log functions. We learned to evaluate log functions, solve log functions, and graph. So here's some questions to think about. Describe what a log function is and what it does. When converting between a log and an exponential, what is true about the base? And why is, oh, I should have the word is in here, why is the x-intercept of a log always 1? That's it. Thanks.